Hello Minecrafters and welcome back to another Redstone video. This is episode 9 of Learning Redstone Computer with Minecraft. In today's episode, we were gonna add the final component to our Redstone computer, which is the data memory. To understand data memory simply, is essentially another register file, but way bigger so we can store much more data and we can read and write data to and from the data memory. This will make our computer super powerful because the more memory we have, the better our computer will be. If you want to understand about data memory a bit more in depth, you should check out Mattbatwings video where he discussed about data memory. In today's episode though, we were gonna try to connect a data memory component to our Redstone computer, and that should be everything about our computer. We can officially call it a fully working Redstone computer that we can just plug a display in the next episode and do some pretty insane stuff with it. But today we were gonna try to connect a data memory to our computer to make our computer super powerful. So without any further waiting, let's just jump right into today's episode, shall we? The very first thing we need to do is we need to design a working data memory. Now this is Mattbatwings data memory that he showed in his video, and as you can see, it's just a bunch of register files stacked next to each other or like placed next to each other. Over here we have the writing data into the register. So if you want to store like this number, like number 7, and you want to store it to address like 15 here, so here's where you can access all of the registers, and here's the data that you want to write. If you want to read, on the other side we have the read output of the data memory, and we also have a lever to control whether we want to read the data inside the data memory or we want to write to the data memory. So this is the lever to control that, and here's the clock signal. Now I have to bring this thing to our world, and we can do that very easily using Mathematica. So I have just selected the bounding box for this component right here. I will now gonna go to area editor, save schematic. I'm gonna name this schematic data memory or something that you can remember, like so. Save the schematic, and we should see our data memory schematic over here. Now we can just go back to our world and paste this thing in, and we should have the data memory inside of our computer world for us to connect it to our computer. Back in our computer world, we have the data memory here. Now the rendering is a bit laggy for my computer because it's very resource intensive. But now if I just press my hotkey for pasting the world in, like the schematic in, we should be able to load in the data memory. Now we're gonna like unload the schematic for the data memory so I don't lag out my computer. But here is the data memory inside of our like computer world. All we have to do now is connect this to our computer, and we should be able to operate some pretty cool like memory manipulation with our Redstone computer. So yeah, let's try to do that. So before we get into connecting, we need to understand how to connect the data memory to our computer, and we can do that by analyzing these two operations, which are the operations for our data memory. The first operation is LOD or load, and this operation has 3 operands: register A, register B, and an offset, and these are 4-bit binary numbers. And what it does, what this operation does is it loads data stored in the data memory at this address. So the address is register A plus an offset, and we're gonna load that data at that address in the data memory to register B in our register file. The store is basically the opposite. So instead of loading, we store. So we store to register B a data that we store like the data from the register B. We're gonna store that to the data memory at this address. So it is address register A plus the offset. This means when this like register A, we're gonna be the address for our that we're gonna be the input for our like data memory. And because we have this addition, we need to use our LRU. In order to do addition, we need to add register A with our offset. And then for the B, it depends on it if it is either load or store. So that's basically what we need to do. We need to feed register A and offset to our LRU to do the addition in order to get the address, and the output of the LRU we were gonna feed it to the data memory. So yeah, let's do that. So hi there, this is me from the future. Basically, the last segment that you have just watched was like 2 months ago. I didn't have a lot of time to continue the project, but I have now finished everything, and I will gonna show to all of you how I connect the data memory with the rest of the computer. The first thing that I did was I add this multiplexer over here, which allows us to select either the output from this register or this value over here, which is the offset value that we were gonna use to navigate inside our like data memory. So the offset value is used to access the address in our data memory alongside the data stored in this register over here. We were gonna add the offset with the data stored at this register, and we're gonna feed the data over there. So the output, the sum of those two values, into our data input over here, or the address input of the data memory. The second thing that I add is another multiplexer over here, and this multiplexer allows us to select either the data coming from the output of the LRU or the output coming from the data memory. I also added another multiplexer down here like so, and this multiplexers can select either the input data line over here or the input data line over here, and those two data line will be fed into the write data of the register file over here. Now I have also modified the data memory that Mattbatwings has here a little bit. So I have removed the read part over here. So previously it's like this to prevent us from the data memory from constantly giving out like a read signal. But due to how I designed this computer, it's a bit wonky, so I had to remove this part in order for everything to work. And also I have also added two more like operations. So these are the last two operations for our computer. The first operation is load, and the second operation is store, and these operations are used to interact with the data memory. So first thing first, these two operations, we're gonna enable our register file, and then over here they both power this line, and this line we're gonna go and power all of the multiplexers that I have show you, and also enable the data memory with this small modification over here. For the second line, only the store operation we're gonna power, not the load operation, because this is the read write function of the data memory. So for load, we don't want to write into the data memory, so we don't select it. But for the store, we want to write into the data memory, so we have to select it. And this line just goes to here, which is the input for read or write of the data memory. And yeah, that's pretty much it. That's all what you have to do. Oh wait, I actually forgot about this. So yeah, I have to wire them like this, using slump block tower like this, and then connect them to the data memory like this. And now that yeah, now I have finished everything, I will gonna show you a test program that I have loaded into the instruction memory, and we were gonna see how everything should work. So there are in total 4 instructions here. At address 0 we have load R1, and we load a number 1 in. And at instruction number 2 we have store R0, R1, and 0. So what this means is we will gonna store the data store at register 1, and we're gonna store that value into memory R0 plus 0. And since R0 has the data of 0 and the offset is 0, we were gonna store the data at memory 0. The third instruction is also the same. We were gonna have a load operation over here, and we're gonna load from memory R0 plus offset 0, and we're gonna load the value stored at that memory to register number 2. So in theory, this part right here, we're gonna load a number 1 into register 2, because at mem 0 we have the number 1 previously loaded into that from the from register 1 in the register 5. Finally, we have the halt signal here, 10001 or 1000. So that's the halt to reset the program. And now we were gonna test everything by hitting this clock signal, and we should see that we should get a number 1 here like so. And here I should probably remove this so you can clearly see that R2 or register number 2 we're gonna receive a number 1 here in just a moment, once like so. And yeah, that's pretty much it. Now the program we're gonna restart because we have hit the halt, and there we go, everything has been fully resetted. And yeah, that's pretty much it for this video and also this series, because we have officially finished everything here. Now of course, for the inputs and outputs, I don't think I'm gonna do it, because I think that's pretty much on you, since every application has some sort of different inputs and outputs, and I can't really cover them all. And also I'm lazy, so that's your job to do. We have already had our fully working computer. Now we can interact with it with using many methods, and it's your job to explore those methods and find which one suits your situation the most. So yeah, that's the end for today's video. Thank you very much for watching. I hope that you have learned a lot of things from this series. I sure have. And I hope that you will be able to create your very own computer. Yeah, thank you very much for watching again, and I will see you all in the next video. Have a nice day, everyone.